Okay, these are some practice questions for the Chapter 2 test for Calculus AB. This was a test we used last year, so we just use some of these for some practice questions. And the first one is the limit as x approaches infinity of the sine of x over x. Okay, that's the first one, and actually there was a little more work to that, so I showed you over here. And again, we know that the sine of x is going to be between -1 and 1. So what we can do is we can multiply through, because as x approaches infinity, 1 over x will be positive. I should state that. As x approaches infinity, 1 over x will be greater than 0. Okay, so we multiply all three parts of this by 1 over x, and we don't have to worry about changing the direction of the inequality. Okay, so this is what we have. -1 over x is less than or equal to sine of x over x is less than or equal to 1 over x. And since the limit as -1 over x equals the limit, as x approaches infinity equals the limit of 1 over x as x approaches infinity, which equals 0. In other words, these two limits both equal 0. All right, they both equal 0, and then since the sign is between these, the sine of x over x is between these, then the limit as x approaches infinity of the sine of x over x equals 0 by the squeeze theorem. By squeeze theorem. Okay, so that was 0. So I just put in 0 up here. Number 2, we just subbed. First thing, always try a substitution. You know, if we tried substitution here, we probably would know what we were going to get here. But intuitively, number 1, you could say that the sign is always going to, the biggest the sign would be 1, and this would be go to infinity, so you still have like 1 over infinity, which would be 0, so that's another way of thinking of it intuitively, if you didn't want to have to use the squeeze limit to prove it. So we just substitute in x over pi over cosine of pi, and the cosine of pi is -1, so we just have pi over -1, which is just negative pi, so that was straightforward substitution. Same thing in number 3, we just substitute. Let's try that. We get 1 squared is 1, minus 1 minus 2 is just -2, and then 1 minus 3 is -2, so we just have -2 over -2 over -2, which is 1. So that was easy. On number 4, we had 0 over 0 if I substitute. Okay, so I get, if I put 1 in here, I get 1, or I'm sorry, -1. If I put -1 here, I get 1, and 5 is 6, minus 6 is 0, and if I put -1 here, I get 0. So we get 0 over 0, so we have to factor. Those cancel, the x plus 1's cancel, so and then we resub, factor and resub, and we get x minus 6. If I put -1 here, I get -1, and -6 is -7, so that worked out nicely. Here's my x goes to infinity, so remember we can do these using the, there's several ways to do this. And, you know, I like to use the end behavior. If I just look at this top as x goes to infinity, the end behavior model for the numerator will be 3x cubed. The end behavior model for the denominator will be x squared, pardon me. And if I simplify this, I get 3x. And the limit as 3x goes to infinity is just infinity. So the limit does not exist. Okay, number 6. And I did this with a little more room over here. I tried to do it over there, but it might have been a little small. So again, we have the limit as x approaches 0 of 1 over x cubed minus 1, well, I'm sorry, 1 over x plus 3 minus 1 over 3 all over x. And if I put 0 in here, I get 1/3 minus 1/3 on the top, so that's 0 over 0 on the bottom. So to simplify it, and it's just a complex fraction, so we multiply the top and the bottom by the LCD, which is 3 times x plus 3. If I multiply the top, here the x, did I say x plus 1? What's wrong with me? Sorry about that. 3 times x plus 1. 3 times x plus 3, pardon me. That's odd. Okay. Okay, so I multiply the top and the bottom by the LCD, which is 3 times x plus 3. And when I multiply the top, these x plus 3's cancel. So I have 3, and then the 3 cancel, so I got x plus 3. And on the bottom, I got 3 times x plus 3. And then if I just remove the parentheses, I get 3 minus x minus 3, all over 3x times x plus 3. And then these 3's cancel, so I got negative x. And then these the x's cancel, I got negative 1 over 3 times x plus 3. So when I canceled those out, I got rid of the factor in the bottom, which was causing trouble. So now I get to substitute, and if I put 0 in for x, I get negative 1 over 3 times 0 plus 3, which is just 3 times 3 is 9, so negative 1/9. Okay, so I hope that makes sense. And we'll do some more next video.